Welcome to Still Science Lab. Tonight, we explore who is the ultimate observer, the quantum God hypothesis. There is a fundamental assumption that underpins every waking moment of your life, a silent agreement you have made with the universe since the day you were born. It is the assumption of objective reality. You believe, with absolute and unshakable conviction, that the physical world exists entirely independently of your awareness of it. When you turn off the light and leave a room, you do not doubt that the walls, the floor, and the furniture remain exactly where they were. When you look up at the moon resting in the night sky, you understand that it is a massive sphere of ancient rock, bound by gravity, ticking along its orbital path regardless of whether human eyes are turned upward to witness it. We are biological creatures evolved to navigate a macroscopic world, and our brains are hardwired to expect a universe composed of solid, definite things. For centuries, classical physics validated this comforting intuition. The cosmos was viewed as a magnificent, predictable machine, a grand clockwork of gears and pendulums set into motion, ticking away in the dark, completely indifferent to the presence of humanity. But exactly 100 years ago, that comforting illusion was violently shattered. As the pioneers of modern science began to peel back the macroscopic layers of reality, delving into the microscopic basement of the cosmos, they did not find smaller gears and tiny clockwork mechanisms. They found something else entirely. They found a realm of existence that defied every logical intuition humanity had ever possessed. Quantum mechanics, the physical framework governing the atomic and subatomic world, exposed a terrifying, structural flaw in our understanding of what it means for something to exist. We discovered that matter, at its very core, refuses to commit. When we isolate the fundamental building blocks of reality, an electron, a photon of light, a single atom, they do not behave like tiny, solid billiard balls flying through the void of space. Instead, the mathematics of quantum theory describes these particles using something called a wave function. This is not a physical wave, like a ripple moving across the surface of a pond, nor is it a wave of acoustic pressure traveling through the air. It is something far more abstract and profoundly unsettling. It is a wave of pure mathematical probability. Before a particle is measured, it does not possess a definite, singular location. It does not possess a definite momentum. It exists in a state of suspended animation, a ghostly superposition of multiple potential realities. The particle is smeared out across space and time, existing merely as a collection of might-bes and could-bes. It is everywhere and nowhere all at once, exploring every possible path and occupying every possible state simultaneously. The universe, at its foundational level, is deeply hesitant. It keeps its options open, existing as a vast, shimmering ocean of infinite potential. But this ghostly state of infinite possibility does not last forever. Something catastrophic happens to the wave function when we attempt to look at it. The very act of taking a measurement, the simple act of placing a detector in the path of the particle to ask it where it is, forces a sudden, violent transition. In that exact fraction of a second, the sprawling wave of probability abruptly collapses. The universe is cornered, interrogated, and seemingly forced to make a choice. Out of an infinite array of potential coordinates, the particle instantly snaps into a single, defined, localized physical reality. It ceases to be a wave of possibility and becomes a hard, tangible point of matter. Physicists call this the measurement problem. It is, without a doubt, the single greatest unsolved mystery in the history of science. Why does the physical state of the universe fundamentally change simply because it is being observed? By what invisible mechanism does the abstract mathematics of probability instantly condense into the concrete reality of matter? There is absolutely nothing in the mathematical equations of quantum mechanics that explains how or why this collapse occurs. The mathematics simply show that it does. The act of measurement acts as a hard boundary between the ghostly quantum realm of potential and the solid classical realm of reality. But what actually causes it? This is not merely a technical puzzle for mathematicians. It is a philosophical nightmare that has haunted physics for a century. The greatest minds who built the architecture of quantum theory, Albert Einstein, Niels Bohr, Erwin Schrödinger, and Werner Heisenberg, realized immediately that they had stumbled into a terrifying paradox. They had engineered the most accurate, successful, and predictive scientific theory in the history of human civilization, yet they could never agree on what the theory was actually describing. They argued fiercely, passionately, and relentlessly about the true nature of the wave function and the meaning of its collapse. Albert Einstein, the great architect of relativity, was deeply disturbed by the implications of the measurement problem. He fundamentally believed in a universe governed by strict cause and effect, an objective reality that existed independent of the observer. Einstein famously asked his colleagues if they truly believed the moon only existed when they were looking at it. He refused to accept that reality was inherently blurry or that the universe relied on the roll of a probabilistic dice. He argued that quantum mechanics must be an incomplete theory, that there must be hidden variables, secret gears turning beneath the surface of the quantum world that dictated the behavior of particles long before we measured them. The particle, Einstein believed, always knew exactly where it was. We were simply too ignorant to see it until the moment of measurement. But Niels Bohr, the brilliant Danish physicist and the father of the Copenhagen interpretation, vehemently disagreed. Bohr argued that there was no hidden, underlying reality waiting to be discovered. He insisted that the wave function was not merely a reflection of human ignorance. It was the complete and exhaustive description of nature itself. To Bohr, it was completely meaningless to ask what a particle was doing or where it was located between measurements. The particle had no defined physical properties until the exact moment it was observed. The observation did not merely reveal reality. The observation actively participated in creating reality. Bohr's interpretation forced a profound surrender of human intuition, demanding that we accept a universe where the act of looking is deeply entangled with the physical existence of the thing being looked at. Erwin Schrödinger, the very man who wrote the fundamental equation governing the wave function, was so horrified by the philosophical implications of his own discovery that he famously created a thought experiment to mock it. He imagined placing a cat in a sealed steel box with a radioactive atom, a Geiger counter, and a vial of poison gas. If the atom decays, the counter triggers the poison, and the cat dies. If the atom does not decay, the cat lives. But because the radioactive decay is a quantum event, governed by a wave function of probability, the atom is simultaneously decayed and not decayed until someone opens the box to look. Therefore, according to the strict rules of quantum mechanics, the macroscopic cat must also be caught in a bizarre superposition, existing simultaneously as entirely alive and entirely dead, until the exact moment a human observer opens the lid. Schrödinger did not propose this paradox to explain quantum mechanics. He proposed it to show how utterly absurd it was to claim that reality remains in a state of suspended probability until a conscious observer forces it to commit. Yet, despite the absurdity, despite the discomfort of Einstein and the mockery of Schrödinger, experiment after experiment over the last century has only confirmed the bizarre truth of the quantum world. The wave function is real. The collapse is real. The universe truly does exist in a state of unresolved probability until a measurement takes place. But this leaves us with a gaping, unresolved void at the very center of physics. The equations of quantum mechanics require a measurement to occur, but they are completely and utterly silent on what actually constitutes a measurement. They do not define what an observer is. Does an observer have to be a conscious human being, possessing a mind and self-awareness? Or can a mindless machine, like a photographic plate or a digital sensor, collapse the wave function on its own? Does a stray photon bouncing off an atom count as an observation? Does a mouse looking at a quantum event collapse reality, or does it require the complex cognition of a primate? After 100 years of relentless debate, the global physics community still has no universally agreed-upon answer to this fundamental question. The observer remains an undefined phantom haunting the machinery of modern science, and it is precisely here, in the undefined shadow of the observer, that the science of quantum mechanics bleeds into a deeply uncomfortable, staggering existential question. We must take this microscopic paradox, this anomaly of atoms and photons, and scale it up to the grand, sweeping timeline of the cosmos itself. Look up into the deep, dark expanse of the night sky. You are looking back into deep time, gazing across a universe that is ancient, silent, and unimaginably vast. Cosmologists have meticulously mapped the history of our universe, tracing its evolution backward through the eons. We know with an astonishing degree of certainty that the universe is roughly 13.8 billion years old. We know that in the immediate aftermath of the Big Bang, the cosmos was a blindingly hot, dense plasma of fundamental particles expanding and cooling in the dark. We know that over millions of years, gravity slowly coaxed the primordial clouds of hydrogen gas to collapse in on themselves, igniting the nuclear fires of the very first generation of stars. We know that these ancient stars burned bright, forged the heavy elements in their cores, and exploded in violent supernovae, scattering the raw materials of reality across the void. We know that from this cosmic dust, galaxies took shape, spiraling majestically in the vacuum, eventually giving birth to solar systems, planets, and moons. This entire, sweeping cosmic history unfolded over billions upon billions of years. It was a violent, beautiful, and strictly physical process. But it was a process entirely devoid of biological life. The primordial oceans of Earth did not host the first, fragile, single-celled organisms until billions of years after the universe began. The first primitive, biological eyes did not open to perceive the light of the sun until hundreds of millions of years after that. For the vast, overwhelming majority of its existence, the universe was completely empty of anything we would recognize as a conscious mind. And this is where the crack in reality threatens to tear the entire narrative of the cosmos apart. If we take the foundational principles of quantum mechanics seriously, we are forced into a logical crisis of epic proportions. If physical matter exists merely as a sprawling wave of probability, refusing to commit to a definite state until it is observed, if the fundamental laws of nature dictate that an observer is absolutely required to force the universe out of superposition and into hard, tangible reality, then who or what was watching the early universe? How did the Big Bang unfold? How did the primordial plasma cool into distinct atoms of hydrogen and helium? How did the first stars ignite and burn in the endless dark? If there were no human beings, no conscious minds, no biological eyes to witness the events, did those early cosmic epochs actually exist in a definite physical state? Or was the entire 13.8 billion year history of the cosmos suspended in a ghostly, uncollapsed wave function, a vast mathematical abstraction hovering in the void, waiting for billions of years for a conscious mind to finally arise and retroactively collapse the entire history of the universe into existence? This is not a question of pure philosophy. It is a question born directly from the rigid mathematics of quantum physics. We are confronted by a temporal paradox that breaks the mind. We know that biological observers are a product of the physical universe. We evolved from the heavy elements forged in the hearts of dying stars. We are made of the universe. But if the physical universe required an observer to become definitively real in the first place, how did the universe ever exist long enough to create the very observers it needed? It is the ultimate cosmic Ouroboros, a serpent devouring its own tail. We cannot exist without a definite physical universe to birth us, but the quantum rules suggest the definite physical universe cannot exist without us to observe it. To resolve this maddening loop, to explain how a universe governed by quantum probability could exist in a definite state for billions of years before the arrival of biological consciousness, many thinkers have found themselves walking down a very strange, isolating road. It is a road where theoretical physics and ancient theology suddenly, unexpectedly intersect. If the act of observation is the fundamental mechanism that weaves the fabric of reality together, and if the universe existed in a solid, definite state long before we were here to witness it, then logic demands that the universe was never truly unobserved. It demands the presence of a primordial witness. It points toward the necessity of a permanent, omnipresent awareness that predates biology, predates the Earth, and predates the stars themselves. If reality requires an observer to become definite, and the universe has always been definite, then we are forced to ask if something has always been watching. This is the profound, unsettling threshold of the quantum God hypothesis. It does not speak of a deity in the traditional, mythological sense, but of an ultimate observer, an infinite, witnessing consciousness woven into the very fabric of the cosmos, whose continuous, unblinking gaze forces the rolling waves of quantum probability into the hard, undeniable reality of the physical world. It is a concept that challenges everything we think we know about physics, reality, and our place in the dark. To understand how we arrived at this staggering hypothesis, we must leave the cosmic scale behind and return to the laboratory, to the very experiment that first fractured our understanding of the world, and look closely at the terrifying power of the act of observation itself. To truly understand the magnitude of the measurement problem, we must leave behind the sprawling, abstract realm of philosophical debate and step into the quiet, sterile confines of the laboratory. The physics laboratory is a sacred space in the modern world. It is an environment designed to strip away human bias, to eliminate the noise of the outside world, and to force the universe to answer our questions under strictly controlled conditions. It is here, among the humming lasers, the vacuum chambers, and the tangled nests of copper wire, that human intuition routinely goes to die. And there is no experiment in the entire history of human science that has dismantled our understanding of reality more thoroughly, more elegantly, and more terrifyingly than the double-slit experiment. The setup is deceivingly simple. In its most basic form, it requires nothing more than a source of particles, a physical barrier with two narrow, parallel slits cut into it, and a blank screen resting a short distance behind the barrier to record where the particles land. To appreciate the profound strangeness of the quantum world, we must first ground ourselves in the predictable, comforting rules of classical physics. Imagine taking a miniature machine gun and firing tiny, solid marbles at this barrier. Most of the marbles will strike the solid wall and bounce away, but some will pass cleanly through the left slit, and some will pass cleanly through the right slit. When they strike the recording screen at the back, they will leave a mark. If you fire thousands of marbles, you will eventually see exactly what your common sense dictates. Two distinct, vertical bands of impact marks, perfectly aligned behind the two slits in the barrier. This is the behavior of solid matter. It is logical, it is physical, it obeys the rules of everyday geometry. Now, imagine flooding the room with a shallow pool of water and generating a continuous wave that ripples toward the exact same barrier. When the crest of the wave hits the wall, the water will push through both the left and right slits simultaneously. As the water emerges on the other side, the two newly formed waves will spread out and crash into one another. In some places, the peak of one wave will meet the peak of the other, amplifying the water into a larger crest. In other places, the peak of one wave will meet the lowest trough of the other, perfectly cancelling each other out, leaving the water dead and flat. When this overlapping, chaotic pattern of water strikes the back wall, it does not leave two distinct bands. It leaves an interference pattern. A wide, alternating series of intense peaks and completely quiet dead zones spread out across the entire screen. This is the fundamental, undeniable signature of a wave. In the macroscopic world, these two identities are entirely separate. A solid marble is a marble. A wave of water is a wave of water. They do not trade places. But when we shrink our experiment down to the foundational building blocks of the cosmos, when we power up a specialized emitter and prepare to fire a beam of electrons or photons at the barrier, the rigid boundary between solid matter and fluid wave completely disintegrates. We know that an electron is a piece of matter. It has a measurable mass. It carries an electrical charge. So, if we fire a stream of electrons through the two slits, our classical intuition tells us we should see two distinct bands on the back screen, just like the marbles. But we do not. When the electrons strike the screen, they arrange themselves into a sprawling, alternating series of bright bands and dark voids. They form a perfect, flawless interference pattern. The electrons, these fundamental units of solid matter, are behaving exactly like a wave of water, rippling through both slits simultaneously and crashing into themselves before hitting the wall. This alone is deeply strange, but early physicists proposed a seemingly rational explanation. They assumed that because we were firing a dense beam of electrons, the particles were simply bouncing off each other as they crowded through the narrow slits, ricocheting in mid-air like a chaotic swarm of bees, and creating a pattern that merely mimicked a wave. To eliminate this possibility, the physicists refined the experiment. They turned down the power of the emitter until it fired only one single, solitary electron at a time. One particle is released. It travels through the vacuum. A tiny flash of light appears on the back screen, marking a single, localized point of impact. We wait. Then, we fire a second particle. Another solitary flash. We fire a third. For hours, the physicists sit in the dark, watching these isolated points of light slowly accumulate on the screen, one distinct dot at a time. Because each electron is entirely alone in the vacuum, with absolutely nothing to bounce off of, it must travel in a straight, logical line through either the left slit or the right slit. It must eventually build up the two distinct bands of a solid object. But as the hours pass and the thousands of individual dots accumulate, a haunting image slowly reveals itself on the screen. The dots do not form two bands. They form the exact same, sprawling interference pattern. The bright zebra stripes of a wave slowly paint themselves in the dark. This is the moment the architecture of reality begins to crack. How can a single, solitary particle, fired completely alone, produce an interference pattern? For an interference pattern to exist, something must be interfering with something else. The chilling, unavoidable conclusion is that the single electron is interfering with itself. When the electron leaves the emitter, it ceases to be a solid point of matter. It dissolves into a wave of pure mathematical probability. It approaches the barrier not as a physical object, but as a ghostly superposition of infinite possibilities. The wave of potential passes through the left slit. It simultaneously passes through the right slit. It passes through neither slit. It bounces off the wall. It explores every single conceivable trajectory across the vacuum at the exact same time. The electron becomes a cloud of localized reality, interfering with its own alternate paths, before finally crashing into the back screen and instantly snapping back into a single, physical dot. The universe is actively refusing to commit. Matter is not solid. It is a flickering hallucination of probability, holding infinite futures in a delicate balance until the final moment of impact. But the human mind is fiercely stubborn. We demand to know how the trick is done. The physicists, desperate to understand how a single particle could possibly travel through two doors at once, decided to outsmart the quantum world. They modified the experiment one more time. They placed a highly sensitive detector right beside the two slits. This device was designed to do one simple thing: watch the electron. It would passively record whether the particle physically went through the left door or the right door. We would finally catch the universe in the act, peering behind the curtain to witness the true behavior of the wave function. The emitter is powered on. A single electron is fired. The detector hums, registering the exact path of the particle. The information is recorded, and in that exact fraction of a second, the universe changes. The moment the detector is turned on, the moment the physical system is observed and the path of the electron is known, the sprawling interference pattern on the back screen completely vanishes. It does not blur. It does not fade. It is instantly and violently erased from existence. In its place, the electrons form two simple, distinct, vertical bands. The moment we look at it, the electron entirely abandons its wave-like nature. It stops exploring multiple paths. It stops existing as a ghost of mathematical probability. It behaves exactly like a solid, mundane marble. This is the terrifying threshold of the measurement problem. The mere act of gathering information, the simple presence of a recording device, physically alters the fundamental nature of the particle. The universe somehow knows that it is being watched, and it instantly drops the veil of quantum mechanics, forcing the particle to choose a single, definitive reality. How does the electron know the detector is there? How does the abstract act of measurement reach out across the vacuum and physically strangle the wave function into submission? The physical machinery of reality is entirely dependent on the knowledge we possess about it. This revelation is so deeply unsettling that for decades, physicists tried to find a mechanical excuse. They argued that the detector itself was to blame. Perhaps the energy required to measure the electron, a stray photon bouncing off it, or a slight magnetic field from the device, was physically bumping the fragile particle, disrupting its delicate wave state and violently knocking it back into a solid form. In this view, the collapse of the wave function was just a clumsy byproduct of our measuring tools, a physical interference rather than a deep philosophical mystery. But theoretical physicist John Archibald Wheeler refused to let the universe off the hook so easily. He realized that if we truly wanted to understand the power of the observer, we had to be infinitely more clever. We had to design an experiment where the measurement could not possibly bump, touch, or physically interfere with the particle in any way. We had to wait to make our choice until it was too late for the particle to physically react. This brilliant, diabolical concept led to the creation of the delayed choice quantum eraser, an experiment so profoundly disturbing that it shatters our fundamental understanding of cause, effect, and the unidirectional flow of time itself. To perform this experiment, physicists use a specialized crystal to take a single photon of light and split it into two identical, entangled twins. These two particles share a single quantum state. Whatever happens to one instantly affects the other, regardless of the physical distance between them. The physicists take the first twin, the signal photon, and send it speeding toward the double slits in the recording screen. They take the second twin, the idler photon, and send it into a complex maze of mirrors and beam splitters. The beauty of this setup lies in the timing. The first photon hits the screen and registers its point of impact very quickly, but the second photon is sent on a much longer journey through the maze of mirrors. The physical distance is carefully calibrated so that the second photon does not reach its own detectors until after the first photon has already crashed into the screen and permanently recorded its position. In this maze, the physicists install a choice. If the second photon hits a certain set of detectors, it reveals the exact, specific path that both photons took through the slits. The which path information is permanently known. But if the photon hits a different set of mirrors, the path information is completely scrambled and permanently erased. The knowledge of which slit the particles went through is lost to the universe forever. Here is where the architecture of reality unravels entirely. The physicists fire the photon. The crystal splits it. The first twin races toward the screen, passes through the slits, and hits the wall. At the exact moment it strikes the screen, the first photon has already completed its journey. Its history is written. Microseconds later, the second twin reaches the end of its maze. The physicists choose to leave the detectors on, gathering the path information. When they look at the pattern left by the first photons on the screen, they see two distinct bands. The photons acted like solid particles. They knew the information was going to be gathered, so they collapsed. Then, the physicists change the maze. They fire the laser again. The first twin hits the screen. Its journey is over. Microseconds later, the second twin hits the scrambling mirrors. The path information is permanently erased. When the physicists look at the pattern left by the first photons, the two solid bands are gone. The sprawling, zebra-striped interference pattern has returned. The photons acted like a wave. Stop and consider the staggering, impossible temporal logic of what has just occurred. The first photon strikes the screen and leaves its mark before the second photon's path is either read or erased. The first photon must somehow decide whether to hit the screen as a wave or as a solid particle, but the event that determines its behavior, the measurement or the erasure of information, has not happened yet. That choice will be made by the scientists microseconds in the future. If the information is erased in the future, the photon acts like a wave in the past, passing through both slits simultaneously. If the information is read in the future, the photon acts like a solid particle in the past, traveling through only one slit. The act of measurement does not merely collapse the wave function in the present moment. It reaches backward across the fabric of time and retroactively rewrites the history of the particle. The observer in the present dictates the physical reality of the past. Cause and effect, the absolute foundational pillars of our logical universe, are inverted. The particle has no fixed history, no definite trajectory, and no objective physical reality until the exact moment the information about it is finally, permanently secured by an observer. The delayed choice quantum eraser proves that the universe does not just care if we are looking. It cares if the information is permanently knowable. If the knowledge exists, the universe is solid, definite, and historical. If the knowledge is destroyed, the universe reverts to a blurry, undefined ghost of mathematics, rewriting its own past to accommodate our ignorance. Time itself is entirely malleable to the presence of an observer. If a simple, laboratory mirror can rewrite the history of a single photon across a fraction of a second, we must look up from the optical tables and face the terrifying implication for the cosmos at large. The universe we inhabit is governed by these exact same quantum rules. The empty space stretching between galaxies, the ancient light of dying stars, the raw material that forged the earth. None of it is exempt from the requirement of a witness. If the history of a particle is not written until it is observed, then the history of the entire universe is a fluid, unresolved draft, waiting for a conscious mind to lock it into place. When we confront the mystery of the wave function and its sudden, violent collapse, our natural instinct is to place the blame on our technology. We look at the double-slit experiment. We see the interference pattern vanish the moment we try to track the particle, and we comfort ourselves with a mechanical explanation. We assume that the cold, lifeless hardware of the detector is responsible. We tell ourselves that a physical machine, with its dense array of copper wiring, silicon chips, and digital sensors, must be physically interfering with the delicate quantum state of the particle. We believe that measurement is a purely physical interaction, a forceful collision between the microscopic world and the macroscopic tools we use to probe it. It is a comforting thought, because it allows us to keep the universe safely objective. It allows us to believe that the physical world is out there, behaving normally, and we are just accidentally bumping into it when we try to look too closely. But as the pioneers of quantum mechanics peered deeper into the mathematics of the collapse, they realized that this mechanical excuse completely falls apart under its own logical weight. To understand why, we must ask a devastatingly simple question. What exactly is a detector? A sensor, a camera, or a Geiger counter is not some magical object that exists outside the laws of physics. A measuring device is just a collection of atoms. It is forged from protons, neutrons, and electrons. And if the fundamental building blocks of reality are governed by the strange, probabilistic rules of quantum mechanics, then the machine constructed from those exact same blocks must ultimately be governed by the exact same rules. This realization led one of the most brilliant mathematical minds of the 20th century, John von Neumann, to uncover a terrifying logical regression. Von Neumann formalized the mathematical framework of quantum theory, and in doing so, he noticed a glaring, inescapable hole in the equations. According to the strict, undeniable mathematics of quantum mechanics, when a particle in a state of superposition interacts with a physical measuring device, the equations do not force a collapse. Instead, the mathematics dictate that the measuring device simply becomes entangled with the particle. Imagine a single electron approaching a barrier, existing as a wave of probability, simultaneously taking path A and path B. The electron enters a physical detector. Because the detector is just a larger physical system obeying quantum laws, it does not magically shatter the wave function. Instead, the detector absorbs the uncertainty. It enters into a massive, sprawling superposition of its own. The machine is now simultaneously in a state of having recorded the electron on path A and having recorded the electron on path B. The blur of probability simply scales up, but the process does not stop there. The detector is connected to a computer monitor, which translates the physical measurement into a glowing pixel on a screen. The computer, being made of physical matter, also becomes entangled. The screen is now in a superposition of displaying two completely different outcomes. Then, the light from the monitor travels across the laboratory and enters the pupil of your eye. The photons of light strike your retina, triggering a cascade of chemical reactions. Your eye is a physical object. The chemical reactions are physical processes. Therefore, your retina simply joins the entanglement. The electrical signal travels down your optic nerve and plunges into the dense, dark neural architecture of your visual cortex. The neurons fire. The synapses bridge the gap. The physical wetware of your brain, constructed entirely of atoms governed by quantum mechanics, absorbs the signal. And because your brain is a physical system, the equations dictate that your brain must also enter a state of superposition. The grey matter inside your skull is simultaneously processing the memory of seeing path A and processing the memory of seeing path B. Von Neumann mapped this unbroken chain of physical interactions and realized that the mathematics of the universe never once provide a mechanism for the collapse. Physical matter interacting with physical matter only creates larger, more complex webs of entanglement. The blur of probability simply infects every physical object it touches, expanding outward like a shadow. And yet, when you look at the screen, you do not experience a blurry, smeared-out superposition of multiple realities. You experience a single, sharp, definite outcome. Von Neumann argued that there is absolutely nothing in the physical laws of the universe that forces the wave function to collapse. The chain of physical entanglement can theoretically stretch on forever, as long as it remains within the domain of physical matter. Therefore, he concluded, the collapse can only occur when the chain finally reaches something that is not entirely governed by physical laws. It must reach the abstract, non-physical, completely unquantifiable realm of human consciousness. In von Neumann's view, it is not the mechanical sensor that collapses reality. It is not the computer, and it is not the optic nerve. It is the invisible, subjective phenomenon of awareness itself. The exact moment the information crosses the threshold from physical matter into the subjective experience of a conscious mind, the universe is forced to commit. Awareness is the anvil upon which the wave function is shattered. This idea was so radical, so entirely opposed to the objective foundations of science, that it deeply unsettled the physics community. It suggested a universe where the human mind was not merely a passive observer watching a mechanical world, but an active, indispensable participant required to finalize the physical state of reality. One of von Neumann's colleagues, the Nobel laureate Eugene Wigner, took this mathematical implication and pushed it to its absolute psychological breaking point. Wigner wanted to explore exactly what happens when consciousness is introduced into the chain of measurement. To do this, he devised a thought experiment that has haunted theoretical physics ever since. It is known as the Wigner's friend paradox, and it forces us to confront the deeply subjective, isolating nature of physical reality. Imagine a perfectly sealed laboratory. It is a windowless, soundproof vault, completely and utterly isolated from the rest of the universe. Not a single photon of light, not a single vibration of sound, not a single fragment of information can escape its walls. Inside this sealed room is a scientist, Wigner's friend. The friend is conducting a simple quantum experiment. They are measuring the spin of a single particle, waiting to see if it registers as pointing up or pointing down. Until the measurement is made, the particle exists in a wave of probability, simultaneously spinning up and down. Wigner's friend turns on the detector, looks at the screen, and takes the measurement. From the perspective of the friend inside the room, the experiment is over. The moment they consciously process the information on the screen, their awareness collapses the wave function. The friend sees that the particle is spinning up. For them, reality has snapped into a solid, definite state. They write the result down in a notebook. They experience a single, objective history. But Eugene Wigner is standing outside the sealed laboratory in the hallway. From Wigner's perspective, the friend, the detector, and the particle are all entirely sealed inside a closed physical system. Wigner has no information about what has happened inside the room. According to the strict mathematical laws of quantum mechanics, because Wigner has not yet made an observation, the entire sealed room remains in a state of quantum superposition. To Wigner, standing in the hallway, the particle is still spinning both up and down. The detector is simultaneously displaying both results, and most terrifyingly, his conscious friend is in a massive state of superposition. From the perspective of the outside universe, Wigner's friend is simultaneously experiencing the memory of seeing the particle spin up and experiencing the memory of seeing the particle spin down. It is only when Wigner finally turns the handle, opens the heavy laboratory door, and asks his friend for the result, that Wigner's own conscious awareness collapses the wave function of the entire room. Only then does the room lock into a single, defined reality for the outside observer. This creates an agonizing philosophical paradox, whose reality is the true, objective reality. For the friend inside the room, the universe collapsed hours ago, the moment they looked at the screen. But for Wigner outside the room, the universe remained a blurry ghost of probability until the exact moment the door was opened. The Wigner's friend paradox suggests that there is no such thing as an absolute, objective reality shared perfectly by everyone. The collapse of the wave function is entirely relative to the specific conscious mind observing it. Wigner took this logic and arrived at a staggering conclusion. He argued that it is mathematically impossible to formulate the laws of quantum mechanics in a fully consistent way without explicitly making reference to human consciousness. He believed that the mind is fundamentally, physically different from the matter it perceives. The atoms in your brain might become entangled, but the subjective, invisible light of your awareness cannot. Consciousness refuses to exist in a superposition, and therefore, it is the only force capable of dragging the physical universe out of the shadows of probability. If we take the implications of von Neumann and Wigner seriously, we are forced to completely invert our understanding of existence. For over 400 years, the scientific consensus has been firmly rooted in the philosophy of materialism. Materialism is the comforting doctrine that the physical universe is the absolute, foundational reality. It tells us that the cosmos is a vast, dead, mechanical theater, filled with mindless energy and unthinking matter. In the classical, materialistic view, space and time existed long before life, and they will continue long after life is gone. Over billions of years, through the blind, chaotic grinding of chemistry and thermodynamics, inert matter randomly arranged itself into biological structures. Biology evolved into nervous systems grew increasingly complex, and eventually, the brain generated consciousness. In this traditional framework, your mind is nothing more than a localized, temporary byproduct of wet matter. Consciousness is an emergent hallucination, a flickering ghost produced by electrical sparks dancing across the synapses in your skull. It is a passive phenomenon, a camera lens recording a universe that does not need it, does not care about it, and would function perfectly well without it. But the quantum observer effect violently dismantles this hierarchy. If physical matter truly requires an act of conscious observation to transition from a wave of probability into a definite, solid state, then consciousness cannot merely be a passive byproduct of matter. It must be the exact opposite. Consciousness must be a foundational, structural component of reality itself. It must be woven into the deepest architecture of the cosmos, sitting at the very base of the existential pyramid. This flips the entire paradigm of the universe on its head. Instead of dead matter accidentally creating the mind is actively required to bake physical matter into existence. The material world becomes derivative. The solid objects around you, the light of the distant stars, the structural reality of space and time itself, all begin to look less like an independent, objective machine and more like a manifestation, reliant entirely on the presence of an observer to give it form. The weight of this awareness is staggering. We spend our lives looking up at the night sky, overwhelmed by the sheer, crushing scale of the cosmos. We see galaxies spanning hundreds of thousands of light years, black holes tearing apart star systems, and voids so vast they defy human comprehension. In the face of this cosmic immensity, we have been taught to feel incredibly small. We have internalized the idea that humanity is nothing but a fragile layer of cosmic dust clinging to a pale blue dot, ultimately insignificant in the grand, sweeping narrative of deep time. We are taught that we are the universe's ultimate accident. But the mathematics of quantum mechanics whisper a very different story. They suggest that our existence is not an accident, and our awareness is not a passive accident. If the universe requires a conscious mind to collapse its probability waves into physical certainty, then the presence of the observer is the most powerful, consequential force in the cosmos. We are not merely standing on the stage, watching the play unfold. The act of watching is what builds the stage. The gaze of the observer is the physical mechanism that forces reality to materialize. This is not a mystical interpretation imported from ancient philosophy. This is the logical extreme of the equations that run our modern world. The mathematics that gave us the silicon chip, the laser, and the smartphone. The mathematics that successfully predict the behavior of subatomic particles to decimal places of unimaginable precision are the exact same mathematics that seemingly demand a conscious observer to function fully. The equations refuse to close without us. Yet, as we absorb the profound importance of the human mind, we immediately run into a temporal paradox so severe it threatens to break our understanding of time itself. We have established that the human mind has the power to collapse reality. We have established that a conscious observer forces the wave function to commit. But biological consciousness is incredibly, devastatingly new to the cosmic stage. The human species has only existed in its current form for a few 100,000 years. Even if we grant the power of observation to the very first, primitive nervous systems that flickered to life in the ancient oceans of Earth, we are only looking back a few 100 million years. But the universe is ancient. The cosmos has been expanding, swirling, and evolving for 13.8 billion years. We know that entire generations of stars ignited, lived out their majestic lives, and died in spectacular supernovae long before our solar system even began to coalesce from the scattered dust. We know that galaxies collided, black holes merged, and the fundamental elements of chemistry were forged in the deep, silent eons of the early universe. We are left staring into a terrifying abyss of logic. If conscious awareness is the required mechanism that forces the cosmos out of a mathematical blur and into physical certainty, how did the universe exist before awareness was born? If there was no mind to look at the early universe, no biological eyes to watch the primordial plasma cool, and no nervous system to collapse the wave function of the first stars, what was the state of reality? Did the first 13 billion years of cosmic history actually happen in a solid, physical state? Or did the entire, sprawling universe exist merely as an uncollapsed, ghostly wave of probability, a vast mathematical phantom waiting in the dark, unable to become physically real until a biological mind finally evolved and opened its eyes to look? To understand the true depth of the quantum paradox, we must step away from the isolated tables of the laboratory and cast our minds outward into the crushing, unimaginable depths of cosmic time. Human beings are creatures of the present moment. We live our lives trapped within a tiny, fleeting sliver of existence, and our biological brains are fundamentally ill-equipped to comprehend the true, sweeping scale of the universe. When we are told that the cosmos is exactly 13.8 billion years old, the number simply washes over us. It is too large to visualize, too vast to feel. But we accept it. We accept the timeline of the universe as a sequence of objective, physical events that marched forward through the dark, much like a grand, mechanical clock ticking away in an empty room. We imagine the birth of the universe as a blinding flash of physical heat, followed by an expanding, tangible cloud of raw plasma. We imagine the very first stars igniting in the void, massive spheres of crushing gravity and roaring nuclear fire, burning fiercely in a universe that had not yet known light. We believe, with absolute intuitive certainty, that this epic history played out exactly as our telescopes suggest. We envision a solid, physical reality that ground forward relentlessly, driven by the blind, mechanical engines of thermodynamics and gravity, until eventually, after billions of years of silent churning, it gave birth to life. But the laws of the subatomic world refuse to allow this comfortable, classical narrative. The strict mathematical rules of the quantum realm have backed us into a philosophical corner, and when we take those exact same rules and scale them up to the entire timeline of the cosmos, the mechanical clockwork of history violently breaks apart. We have established a terrifying foundational truth about the nature of reality. A physical system does not exist in a definite, localized state until it is forced to commit. We know that physical matter exists merely as a sprawling wave of mathematical probability, a shimmering ghost exploring all possible outcomes simultaneously, until an act of measurement forces that probability to collapse into a single reality. Now, take that rigid, unyielding mathematical law and apply it to the dark, silent dawn of time. Travel backward through the eons. Move past the dawn of human civilization, past the brief, chaotic flicker of our recorded history. Move past the age of the great reptiles, past the crawling amphibians hauling themselves out of the water and onto primordial shores. Move backward to a time roughly 4 billion years ago, when the very first primitive single-celled organisms flickered to life in the boiling, toxic oceans of the early Earth. Before that singular, monumental moment, our planet was a sterile, lifeless rock floating in the dark. There were no biological eyes to process the harsh light of the young sun. There were no primitive nervous systems to feel the tactile vibration of the wind carving through the barren canyons. There was absolutely no biological consciousness, no awareness, and no observing mind present anywhere on the globe. And yet, the Earth itself is only 4.5 billion years old. The universe existed for over 9 billion years before our world was even a swirling cloud of interstellar dust. What happened during those 9 billion years? If reality only becomes definite when it is observed, what was the physical state of the cosmos before the first biological eye ever opened? It is here that we must paint a picture of a universe that utterly defies all human intuition. Imagine the cosmos not as a physical, tangible place, but as a vast, uncollapsed superposition of states. In the absence of a conscious mind to lock reality into place, the entire universe was a ghostly, shimmering phantom of pure mathematical probability. When the primordial clouds of hydrogen gas began to gather in the ancient dark, pulled together by the relentless, invisible tug of gravity, they did not form solid, definite stars. Without an observer present to force a collapse, the strict laws of quantum mechanics dictate that those massive clouds existed in a state of suspended animation. They were simultaneously collapsing and not collapsing. The first generation of stars, the massive, violent engines that theoretically lit the early universe, were simultaneously burning with nuclear fire and remaining perfectly, absolutely dark. They existed in every possible state at once, their immense gravitational weight and their nuclear potential suspended in a cosmic scale blur. The ancient galaxies that began to spiral in the void did not possess a single, defined shape. They were smeared out across billions of light years, their spiral arms existing as a vast, vibrating equation waiting for a solution. Black holes, the great gravitational anchors of the cosmos, were simultaneously tearing through the fabric of space-time and not existing at all, their event horizons hovering in a spectrum of mathematical potential. This is not a poetic metaphor. It is the logical, unavoidable conclusion of the equations we use to define modern physics. The mathematics do not care about the size of the object. Whether it is a single electron or a supermassive black hole, if you remove the observer, you entirely remove the mechanism of collapse. And without that collapse, the wave function of the universe simply continues to evolve in the dark, expanding and entangling with itself, creating a staggering, cosmic-scale blur of overlapping realities. The universe was a silent, unwritten draft. It was an unfathomable architecture of pure information, a dark, churning ocean of what-ifs and might-be's, spanning billions of light years, waiting patiently for a witness to force it to become real. But this ghostly, beautiful vision of the early universe creates a devastating logical crisis. It brings us face to face with the ultimate paradox of physical existence. We know, with absolute, undeniable certainty that the universe eventually birthed conscious observers. You are here. You possess a mind. You are listening to these words, processing complex information, and actively observing the physical world around you. We also know that your physical body, the very biological machinery that allows you to be conscious, is constructed entirely from heavy elements. The carbon forming the structure of your cells, the iron binding the oxygen in your blood, the calcium fortifying your bones. Absolutely none of these elements were created in the immediate aftermath of the Big Bang. They were forged in the crushing, unimaginable heat at the core of the very first stars. They were fused together in the dark and then cast out into the interstellar void by violent, ancient supernovae. Over billions of years, that scattered cosmic debris drifted across space, eventually coalescing to form the Earth, the primordial oceans, and ultimately, you. Here is the paradox that threatens to break the rational mind, a chicken and egg problem scaled up to the size of the cosmos. We are the observers. We are the biological entities supposedly required to collapse the quantum wave of probability into physical, historical reality. But we are constructed entirely from the physical debris of ancient, dead stars. If the universe fundamentally required an observer to become physically real in the first place, how did those ancient stars ever physically exist to forge the very elements that made us? How can a ghostly, uncollapsed wave of mathematical potential undergo the physical process of nuclear fusion? A probability wave cannot forge iron. An abstract mathematical equation cannot explode in a physical supernova. A superposition of states does not experience thermodynamic entropy. The universe desperately needed those early stars to be solid, definite, and physically real in order to create the biological observers. But the rigid rules of quantum mechanics suggest those exact same stars could not be solid, definite, and physically real until the biological observers finally arrived to look at them. How do we escape this impossible, agonizing loop? Some brilliant, highly unorthodox thinkers in the realm of theoretical physics have proposed a solution that is almost too bizarre to comprehend. They suggest that when the first conscious, biological mind finally flickered to life in the universe, its very first act of observation reached backward across the fabric of time. They argue that the awakening of consciousness retroactively collapsed the entire 13.8 billion-year history of the cosmos. In this staggering view, the moment a primitive, biological eye opened in the dark and perceived the light of a distant star, it forced that star to have existed physically in the ancient past. The observation in the present forced the supernova to have exploded billions of years ago. It forced the heavy elements to have been forged in the dark. The present observer essentially wrote the physical history of the past, collapsing the ghostly wave function of the entire universe in a single, retroactive cascade of reality. The universe, in this model, is a self-creating loop, pulling itself into physical existence by the sheer, retroactive force of its own future observation. It is a breathtaking concept, a profound testament to the wild, unrestrained imagination of theoretical physics. It suggests that the past is not a fixed, unyielding monument, but a fluid potential that is constantly being cemented into reality by the consciousness of the present. But it is also a concept that strains the limits of rational logic to their absolute breaking point. It demands that we accept a universe that is a living paradox, a cosmic snake devouring its own tail. It requires us to believe that the solid, historical foundation of reality is merely a retroactive illusion, painted backward across the eons by the fragile minds of the creatures it eventually created. It asks us to believe that an abstract probability wave waited in the dark for 9 billion years, somehow managing to physically evolve a planet and a nervous system while simultaneously not existing as a definite physical reality. For many scientists and philosophers, this is an unacceptable, almost desperate leap of logic. It feels like a frantic attempt to force the universe into a conceptual box that it clearly does not fit inside. The retroactive collapse theory requires too many logical leaps, too many violations of cause and effect to serve as a stable foundation for our understanding of reality. If we reject the idea of a retroactive, self-creating universe, we are left standing on the edge of a profound, inescapable void. The paradox remains, staring back at us. The timeline of the cosmos is real. The ancient stars truly burned. The galaxies formed, spinning in the dark. The heavy elements were forged over billions of years of silent, physical, thermodynamic history. The universe was definitively, undeniably, and physically real long before biological consciousness ever flickered to life on this tiny, insignificant planet. But the ironclad mathematics of the quantum world still stand. The equations remain unbroken. They still demand a collapse. They still require a mechanism to translate probability into absolute certainty. They still require a witness to force the universe out of superposition. We are forced, by the sheer weight of physical evidence and mathematical necessity, to admit that our definition of the observer is fundamentally incomplete. If the universe existed in a hard, physical state before the arrival of human beings, and if a physical state requires an act of observation to become real, then humanity is not the primary observer. Biological life is not the required trigger for reality. The universe was never a ghostly mathematical phantom waiting for a primitive eye to open on a rocky, waterlogged planet. The universe was already solid. It was already defined. The quantum waves of probability were already collapsing in the dark, billions of years before we were here to ask questions about them. This realization sends a profound tremor through the foundations of everything we think we know about existence. It means that the universe was never truly alone. During those vast, silent eons before the first cell divided, before the earth coalesced from the dust, before the light of the first star pierced the primordial darkness, the act of measurement was already taking place. Something was already forcing the cosmos to commit to a definite history. The mathematics of reality point directly toward a profound, unseen presence woven into the very fabric of space-time. If the physical universe requires a knower in order to exist, and the universe clearly existed long before us, then we must confront the possibility that the cosmos has been known from the very beginning. We must confront the staggering, unavoidable necessity of a primordial witness. A presence that does not rely on biological eyes or neural pathways, but an awareness that is intrinsic to the universe itself. We are led by the equations, step by step, to a threshold where science and ancient philosophy collide. We are led to ask what kind of observer could possibly hold a 13.8 billion-year-old universe in place simply by the act of watching. There is a profound, almost uncomfortable boundary where the rigid, unforgiving world of mathematics dissolves into something far older and far more mysterious. For centuries, the entire enterprise of modern science has been built upon a singular, foundational premise. The physical universe is an objective, mechanical reality that operates entirely on its own. Ever since the scientific revolution, the ultimate goal of physics was to banish the subjective, to remove the human mind from the equation, and to describe a cosmos that functioned like a perfect, giant clockwork. The planets orbited the sun, the oceans rose and fell with the tides, and the stars burned in the ancient dark, all driven by blind, uncaring physical laws. When the French mathematician Pierre-Simon Laplace presented his majestic model of the solar system to Napoleon Bonaparte, the emperor famously pointed out that Laplace had not mentioned a creator anywhere in his vast work. Laplace simply replied that he had no need of that hypothesis. Science was the business of explaining the physical world without invoking the supernatural. The universe was a machine, and it did not require a divine engineer to keep the gears turning. But the discovery of the quantum wave function and the terrifying reality of its collapse completely shattered that mechanical illusion. We have followed the equations of quantum mechanics to their logical, inescapable extreme. We have established that physical matter refuses to commit to a definite state until it is forced to do so by an act of observation. We have stared into the temporal paradox of a 13.8 billion-year-old universe that desperately required a witness to lock its history into place long before biological eyes ever evolved to look at it. The mechanical clock of the cosmos, it turns out, cannot tick in the dark. It requires a conscious mind to tell the gears exactly where to be. This brings us to the threshold of the most profound, unsettling convergence in the history of human thought. It is the arrival at a single, unavoidable door by physicists, philosophers, and theologians, all of whom began their journeys from completely different directions. If the universe cannot exist in a definite, physical state without an observer, and if the universe existed as a solid, historical reality long before biological life flickered into existence on a tiny, insignificant planet, then rational logic points toward a singular, terrifying necessity. There must be a permanent, omnipresent observer. This is the core of the quantum God hypothesis. It is not a concept born from ancient scripture, mythological tradition, or spiritual revelation. It is a concept dragged, reluctantly and kicking, out of the sterile laboratories of theoretical physics. It is a hypothesis forged in the fires of mathematical necessity. When the greatest minds of the 20th century realized that the observer could not be removed from the quantum equations, they unwittingly opened a door that science had spent 400 years trying to permanently nail shut. To understand the sheer magnitude of this idea, we must completely discard the mythological baggage we carry when we hear the word God. The quantum God hypothesis does not propose a bearded patriarch sitting on a cloud. It does not speak of an anthropomorphic deity hurling lightning bolts, judging human morality, or interfering with the trivial affairs of biological creatures on Earth. This is not the God of Sunday school. Instead, it asks us to conceptualize God as the ultimate observer. It asks us to imagine an infinite, foundational consciousness that permeates the entirety of space-time. This is an awareness that does not rely on biological optical nerves, digital sensors, or physical brains to perceive reality. It is a presence that is woven into the very fabric of existence itself, a cosmic gaze that covers every microscopic coordinate of the universe simultaneously. Imagine the early universe, billions of years before the Earth was formed. The ancient, primordial clouds of hydrogen gas are swirling in the void, pulled by the relentless grip of gravity. Without an observer, these massive stellar nurseries would exist merely as ghostly, uncollapsed waves of mathematical probability, shimmering across the dark. But the ultimate observer is there. Its absolute, unbroken awareness saturates the void. And simply by the act of being present, simply by the sheer, unavoidable fact of its universal witnessing, the quantum probability of the universe is violently and continuously forced into hard, physical reality. The stellar nurseries collapse into definite, burning stars. The supermassive black holes anchor the spinning galaxies. The heavy elements are forged in the nuclear furnaces of the cosmos, not as abstract mathematical potential, but as solid, undeniable matter. In this framework, the physical universe does not exist independently, nor was it simply created in a single moment and left to run on its own. Instead, physical reality is a continuous, ongoing manifestation held together fraction of a second by fraction of a second by the gaze of the ultimate observer. The act of creation was not a single event in the ancient past. It is an active, eternal process happening everywhere, all at once. The existence of the physical world is entirely dependent upon the fact that it is being known. This idea echoes a profound philosophical concept proposed in the early 18th century by the Irish philosopher George Berkeley. Long before anyone knew what an electron or a wave function was, Berkeley argued that the material world did not exist in any absolute, objective sense. He proposed a philosophy known as subjective idealism, famously summarized by the Latin phrase esse est percipi. To be is to be perceived. Berkeley argued that a tree falling in a forest makes no sound if no one is there to hear it. In fact, the tree itself ceases to exist if it is not being perceived by a conscious mind. Classical physicists mocked Berkeley's philosophy as absurd mysticism. If reality ceases to exist when we turn our backs, they argued, why is the world so incredibly stable? Why does the tree remain exactly where we left it when we return? Berkeley's answer was elegantly simple, yet profoundly challenging. He argued that the physical world remains stable and consistent when humans are not looking, because it is permanently, constantly being perceived by the infinite mind of God. For hundreds of years, science dismissed Berkeley's invisible, observing God as an unnecessary fantasy. But the arrival of quantum mechanics has arguably resurrected Berkeley's ghost, dressing his 18th century philosophy in the rigorous, terrifying mathematics of the 20th century. When the physicist John von Neumann traced the chain of quantum entanglement from the measuring device to the human brain and concluded that consciousness was required to collapse the wave function, he was unwittingly building a mathematical bridge right back to Berkeley's ancient premise. If human consciousness collapses the wave function of a single laboratory experiment, then an infinite consciousness is required to collapse the wave function of the entire universe. The quantum God hypothesis provides a flawless, elegant solution to the measurement problem that has haunted physics for a century. It removes the agonizing paradox of Wigner's friend, the nightmare of subjective, isolated realities where the universe collapses for one person but remains blurry for another. If there is an ultimate observer, an infinite awareness perceiving the entire cosmos from a vantage point outside of the physical system, then there is an objective, shared reality after all. The universe is not a chaotic, fragmented hallucination unique to every individual human mind. It is a single, unified, definite reality because it is permanently being witnessed from above, holding the physical laws, the stars, and the planets firmly in place. But this solution comes with an intellectual price that many modern scientists are incredibly hesitant to pay. It demands that we abandon the comforting doctrine of materialism. It forces us to admit that consciousness is not a late, accidental byproduct of the universe, but the absolute foundation of it. It suggests that mind is older than matter. To grasp how this works at a physical level, we must look at what the act of measurement actually is. In the laboratory, the delayed choice quantum eraser experiment taught us that the universe collapses into reality not when it is physically bumped or touched, but when information about it becomes permanently knowable. The collapse is driven by the acquisition of knowledge. Therefore, the ultimate observer does not need to physically interact with the cosmos to hold it in place. The ultimate observer is simply the ultimate repository of information. Imagine the universe as an unfathomably vast, complex ledger of data. Every particle, every spin, every coordinate of momentum is a piece of information. When a particle is in a state of quantum superposition, that specific line in the ledger is left blank, hovering in a state of unresolved potential. The moment a human scientist measures the particle, they fill in that blank line, and the particle snaps into reality. But the ultimate observer already possesses the entire ledger. The infinite awareness inherently knows the state of the universe, and because the information is known by the cosmos itself, the wave functions are constantly, instantly collapsing, generating the solid, physical world we walk through every single day. In this view, the universe is not a giant, mechanical machine. It is something much closer to a great, sprawling thought. It is an arena of awareness. The heavy, tactile sensation of gravity pulling you against the earth, the blinding heat of the sun against your skin, the solid, unyielding texture of the ground beneath your feet. These are not the properties of dead, unthinking matter. They are the physical symptoms of an ongoing, cosmic observation. You are existing within the mind of the universe. This realization transforms our entire relationship with the dark, empty spaces of the cosmos. When we look up at the night sky, we are often struck by a profound sense of isolation. We stare into the black voids between the stars and feel the crushing weight of our own insignificance. We imagine the universe as a vast, uncaring void, a cold theater of physics entirely indifferent to our existence. But the quantum God hypothesis whispers a radically different story. It suggests that there is no true emptiness anywhere in the cosmos. There is no dead, unobserved corner of the universe. The darkest, most remote regions of intergalactic space, billions of light years away from any biological eye or primitive nervous system, are entirely saturated with the exact same awareness that collapses the atoms in your own hand. The universe is awake. It is a deeply participatory arena, held together by a silent, unbroken act of witnessing. This concept blurs the lines between theology and astrophysics in ways that challenge the deepest dogmas of both. For the strict materialist, the idea of an omnipresent consciousness feels like a betrayal of the scientific method, a retreat into ancient superstition to cover the gaps in our current understanding. For the traditional theologian, the idea of God as an impersonal, mathematical observer collapsing wave functions strips away the comforting, personal nature of a loving deity, reducing the divine to a cold, structural law of physics. Yet, for those willing to stand at the intersection of these two worldviews, the quantum God hypothesis offers a breathtaking synthesis. It offers a vision of reality where science and spirituality are not opposing forces, but two different languages trying to describe the exact same underlying truth. The mystic who claims that all things are connected in a universal mind, and the physicist who maps the entangled wave function of a quantum field are suddenly seen staring at the exact same cosmic architecture. If this hypothesis is true, if the universe is indeed an ongoing thought held in a definite physical state by a universal witness, then human consciousness takes on a profoundly beautiful, entirely new meaning. We are no longer accidental anomalies, lonely sparks of biological awareness isolated on a rock in the middle of nowhere. If the foundational reality of the cosmos is an infinite, observing mind, then our own, fragile human minds are not anomalies at all. We are localized, concentrated expressions of the very fabric of the universe. When you open your eyes and observe the world around you, when you look through a telescope at a distant galaxy, or when you simply watch a particle strike a screen in a laboratory, you are not a separate entity looking at a dead machine. You are the universe's awareness, folded into a biological form, participating in the continuous, eternal act of creation. The observer effect is not a glitch in the mathematics. It is the fundamental signature of a living cosmos. We are forced to sit with the sheer, immense gravity of this concept. The physical reality of your own body, the chair you are sitting in, and the atmosphere you are breathing only exists in a solid, concrete state because it is being known. You are held in existence, fraction of a second by fraction of a second, by an unbroken cosmic gaze. But science demands skepticism. It demands rigorous interrogation, and it demands that we test every possible alternative before we surrender the objective universe to the realm of infinite consciousness. Theoretical physics is not built on faith. It is built on equations, and there are many brilliant minds who refuse to accept that the mathematics of the quantum world require a God, an ultimate observer, or any kind of consciousness whatsoever to function. To maintain the integrity of our journey, we must step back from the edge of theology and examine the raw, underlying code of the cosmos itself. We must ask if there is a way to explain the collapse of the wave function without invoking a mind. We must ask if reality is not built out of matter and not built out of awareness, but built entirely out of something else, pure, mathematical information. If we pull back from the very edge of theology, from the concept of a divine, omnipresent witness holding the physical world in place, we are forced to ask if there is another way to interpret the chilling silence of the quantum void. What if the solution to the measurement problem does not require us to redefine the observer, but rather requires us to completely dismantle our understanding of what is being observed? For centuries, we have approached the mysteries of the cosmos with a deeply ingrained bias. We have assumed that the universe, at its absolute foundation, is made of stuff. We believe in substance. We believe in energy and matter, fields and forces, the tangible raw materials that supposedly construct the scaffolding of reality. But what if matter is not the bottom layer of existence? What if the physical universe is merely an illusion, a highly convincing projection generated by something entirely invisible, abstract, and profoundly strange? To navigate this radical departure from traditional physics, we must follow the vision of a man who stood at the very center of 20th century science. John Archibald Wheeler was not a fringe theorist or an idle philosopher. He was a titan of theoretical physics, a man whose intellectual fingerprints are scattered across the most profound discoveries of the modern age. He was a collaborator with Albert Einstein, striving to unify the laws of relativity with the quantum world. He was the mentor to Richard Feynman, helping to birth the modern framework of quantum electrodynamics. He was the physicist who gave the world the term black hole, bringing the terrifying mathematical anomalies of collapsed stars into the mainstream consciousness. Wheeler was a man deeply rooted in the rigorous, unforgiving mathematics of physical reality. And yet, toward the end of his long and brilliant life, after decades of staring into the equations that govern the universe, Wheeler experienced a profound shift in perspective. He divided his own legendary career into 3 distinct phases. In the first phase, he believed that everything was made of particles. In the second phase, as quantum field theory matured, he believed that everything was made of fields. But in his third and final phase, Wheeler arrived at a conclusion so breathtakingly unorthodox that it continues to send shockwaves through the physics community today. He concluded that the universe is not fundamentally made of matter, and it is not fundamentally made of fields. He declared that everything is made of information. Wheeler summarized this monumental paradigm shift in a simple 3-word phrase that has become a cornerstone of modern theoretical physics: it from bit. To understand the staggering implications of it from bit, we must break the phrase down. The it represents every physical thing in the cosmos. Every electron, every photon of light, every atom of carbon in your DNA, the crushing gravity of a black hole, and the vast, sweeping arms of a spiral galaxy. The it is the physical reality we perceive and measure. The bit represents the fundamental unit of information, exactly like the binary code used in modern computing. A bit is a simple, indivisible answer to a yes or no question. It is a 1 or a 0, true or false, here or there. Wheeler argued that every physical it in the universe derives its entire existence, its mass, its spin, and its location, directly from a discrete series of these binary bits. The physical world is not the foundation of reality. It is the byproduct of information processing. The universe, in Wheeler's vision, is an immaterial arena of questions and answers. To visualize how reality could possibly be constructed from questions, Wheeler offered a brilliant, illuminating analogy based on the parlor game 20 Questions. In the traditional version of the game, someone leaves the room, and the remaining players agree on a specific word or object. When the person returns, they must guess the object by asking a series of yes or no questions. Is it alive? Yes. Is it an animal? No. Is it a plant? Yes. With every binary answer, the realm of possibility shrinks, until finally the questioner arrives at the predetermined physical object. In this classical version of the game, the object exists in a definite physical state before a single question is even asked. The questions merely uncover a reality that is already there. But Wheeler imagined a very different, deeply unsettling version of this game. Imagine you leave the room, and while you are gone, the players decide to play a trick on you. They agree not to choose a word at all. There is no predetermined object. The room is completely empty of a specific reality. You return and begin asking your questions. Is it alive? The first player, having no word in mind, simply makes up an answer and says yes. Is it an animal? The second player, now constrained by the first player's answer, says no. The game continues, passing from player to player. Here is the brilliant twist. Every time a player answers yes or no, they are entirely free to choose, as long as their answer logically aligns with all the answers that came before it. As you ask more and more questions, the web of constraints grows tighter and tighter. You are not uncovering a pre-existing object. You and the players are collaboratively building the object out of thin air, piece by piece, binary choice by binary choice. When you finally ask, is it a redwood tree? And the final player says yes, a redwood tree has been brought into existence within the context of the game. But that tree did not exist when you walked into the room. It was forged in the fire of the questions you chose to ask. Wheeler realized that this is exactly how the quantum universe operates. When a particle is in a state of superposition, drifting through the dark as a ghostly wave of probability, it does not possess a definite physical state. There is no predetermined object waiting to be uncovered. It is only when we set up a detector and take a measurement that we force the universe to provide a binary answer. Did the electron go through the left slit or the right slit? Is the spin pointing up or pointing down? The detector asks a yes or no question, and the universe provides a bit of information in response. The physical particle we observe on our screens is nothing more than the physical manifestation of that information. The electron does not exist as a solid entity that happens to possess information. The electron is the information. Reality is a digital output. The universe is not a grand clockwork machine. It is a sprawling, incomprehensibly complex network of binary responses, a self-organizing system of logic that only takes on a physical form when it is interrogated by an observer. This brings us to the most radical and deeply profound implication of Wheeler's framework. If the physical universe is forged entirely from the answers to questions, we must inevitably ask, who is asking the questions? The answer is us. The observer is not a passive audience member sitting in a darkened theater, watching a cosmic play unfold on a stage. The observer is the engine of reality itself. Wheeler called this the participatory universe. He proposed that the cosmos is a massive, self-excited circuit, a feedback loop of information that requires the presence of a knowing mind to actualize its own existence. To illustrate this mind-bending concept, Wheeler drew a now famous diagram. He imagined the entire history of the universe as a simple, elegant line curving through the dark, bending around to form the shape of a massive letter U. The right side of the U represents the fiery, chaotic birth of the cosmos in the Big Bang. As the line curves downward, it represents the billions of years of silent, physical evolution. The cooling of the plasma, the formation of the galaxies, the slow, blind churning of stellar chemistry. The line sweeps across the bottom and begins to rise up the left side, representing the birth of planets, the emergence of biology, and the slow, agonizing climb of evolution. Finally, At the very top of the left side, the line culminates in a single, open eye. That eye is us. It is the conscious, observing mind, looking backward across the vast expanse of time, staring directly at its own origin on the other side of the curve. In a classical, materialist universe, that eye is nothing more than a late, accidental consequence of the Big Bang. But in Wheeler's participatory universe, the eye is actively required to give physical reality to the origin itself. By observing the cosmos, by asking questions with our telescopes, our particle accelerators, and our conscious minds, we are generating the bits of information that lock the universe into a definite state. The universe birthed us so that we could look back and realize the universe. The cosmos is not a dead, uncaring void. It is a system that leans toward a knower, hungering for an observer to pull it out of the shadows of probability and into the hard light of existence. But this elegant, self-referential loop forces us to confront the exact same terrifying temporal paradox we encountered before. How can we, existing today, give physical reality to a universe that is almost 14 billion years older than our species? If reality is created by the questions we ask in the present moment, what happens to the deep past? Wheeler did not shy away from this paradox. He embraced it, utilizing the exact same logic established by the delayed choice quantum eraser experiment, but scaled up to the most staggering cosmic proportions imaginable. Imagine a quasar, an incredibly bright, violent core of a distant galaxy sitting billions of light years away from Earth. Between this ancient quasar and our planet lies another massive galaxy. According to the laws of general relativity, the intense gravity of the middle galaxy warps the fabric of space-time around it, acting as a colossal magnifying glass. When a photon of light leaves the ancient quasar and travels toward Earth, it encounters this gravitational lens. The photon can take one of two paths. It can bend around the left side of the galaxy, or it can bend around the right side. Because this is a quantum event, the photon does not choose. It enters a state of superposition. For billions of years, this single particle of light travels through the freezing, empty intergalactic void as a ghostly wave of probability, taking both paths around the massive galaxy simultaneously. It travels through the dark while entire species evolve and go extinct on Earth. It travels while continents drift and oceans freeze. It remains in a state of suspended animation, a purely mathematical potential, waiting for a question to be asked. Tonight, an astronomer on Earth points a powerful telescope at the sky and decides to measure that exact photon. The astronomer has a choice. They can set up the telescope to measure exactly which side of the galaxy the photon went around, or they can set up the telescope to recombine the paths, erasing the information and looking for a wave-like interference pattern. Just like in the laboratory, the choice made by the astronomer tonight determines the physical behavior of the photon. But this photon has been traveling for billions of years. If the astronomer chooses to measure the exact path tonight, the wave function collapses, and the photon must have traveled as a solid, definite particle past only one side of the galaxy billions of years ago. The decision made by a human being looking through a lens in the present moment reaches backward across the eons, across billions of light years of empty space, and retroactively forces the photon into a definite physical history. This is not a fringe theory or a science fiction fantasy. It is the inescapable logic of quantum mechanics, famously proposed by Wheeler and subsequently proven in sophisticated astronomical observations. We are not just observing the ancient universe, we are actively creating it. Every time we point a telescope into the deep dark, every time we capture the faint, red-shifted light of the cosmic microwave background, we are asking a yes or no question. We are generating a bit of information, and in doing so, we are continuously, retroactively carving out the physical reality of the Big Bang from the raw, undefined clay of quantum probability. We are sculpting the past from the present. The history of the cosmos is not a fixed, immutable monument left behind in the dark. It is a fluid, ongoing negotiation between the observer and the observed. The universe did not simply happen 14 billion years ago. The universe is happening right now, at the exact moment of observation. This informational view of reality fundamentally shifts our existential place in the cosmos. It relieves the heavy, theological burden of requiring a singular, omnipresent God to hold reality in place, while simultaneously destroying the bleak, nihilistic worldview of strict materialism. We are not the passive victims of a cold, mechanical universe, nor are we isolated anomalies trapped on a dying rock. We are an integral, structurally necessary component of the cosmic architecture. We are the mechanism by which the universe processes its own existence. When you look down at your hands, when you feel the rhythm of your breath, and when you look up to witness the faint, ancient light of the stars, you are not merely experiencing reality. You are generating it. We are the universe's sensory organs. We are the cosmos waking up, rubbing its biological eyes, and looking back at itself in awe. The universe is a vast, silent question hovering in the dark, and consciousness is the answer. But science is an arena of relentless skepticism. As deeply beautiful and philosophically satisfying as the participatory universe may be, the scientific method demands that we seek the simplest, most objective explanations before we elevate human consciousness to the role of cosmic architect. There is a formidable camp of physicists who look at the exact same quantum equations, the exact same experiments, and the exact same wave functions, and draw a completely different, profoundly sobering conclusion. They argue that the observer is an illusion. They argue that reality requires no consciousness, no information processing, and no God to collapse into existence. To truly understand the measurement problem, we must step out of the realm of philosophy and plunge into the cold, mechanical reality of quantum decoherence and hear the skeptics make their final, devastating case. There is a profound, intoxicating comfort in the idea that the universe requires our presence to exist. The notion that human consciousness, or the gaze of an infinite divine mind, is the foundational pillar of physical reality feels deeply right to our biology. We are storytellers by nature, and we desperately want to be the main characters in the narrative of the cosmos. The participatory universe, the quantum God, the mind acting as the ultimate architect of matter. These are beautiful, sweeping concepts that place meaning at the very center of the void. But theoretical physics is an incredibly brutal and unforgiving discipline. It does not care about our philosophical comfort. It does not care about elegance if that elegance requires unnecessary magic. The scientific method is a ruthless editor, driven by the principle of Occam's razor. We must never multiply entities beyond necessity. Before we rewrite the foundational laws of nature to place a conscious observer or an omnipresent deity at the helm of reality, we are obligated to ask a sobering, cold water question. What if the mysteries of the quantum world can be explained entirely by the blind, mindless, mechanical interactions of dead matter? To hear the skeptic's case, we must step out of the pristine, idealized environments of our thought experiments. In our minds, when we picture a solitary electron existing as a wave of pure mathematical probability, we imagine it floating through a perfect, absolute vacuum. We imagine a realm of total silence, completely isolated from the rest of the universe, where the delicate superposition of states can hover undisturbed indefinitely. But the actual universe is not a perfect vacuum. The cosmos is unimaginably messy. It is loud, chaotic, and relentlessly crowded. Even in the darkest, most remote depths of intergalactic space, the void is boiling with activity. Space is completely saturated with the leftover thermal radiation of the Big Bang, a ceaseless blizzard of ancient microwave photons. It is filled with stray cosmic rays, wandering neutrinos, and the faint, overlapping gravitational ripples of distant merging black holes. In the macroscopic world of our daily lives, this physical noise is deafening. The air in the room around you is a chaotic storm of trillions of nitrogen and oxygen molecules violently colliding with one another billions of times every second. Everything is touching everything else. Everything is radiating heat. This inescapable cosmic noise is the absolute enemy of the quantum wave function, the ghostly state of superposition, where a particle exists in multiple places or multiple states simultaneously, is incredibly fragile. It relies on a property called quantum coherence, a perfect, unbroken synchronicity within the wave of probability. You can think of it like a beautiful, complex symphony being played by a massive orchestra. As long as every instrument is perfectly tuned and perfectly isolated from outside distractions, the intricate harmonies hold together, and the symphony exists as a single, unified piece of music. But what happens when you take that delicate symphony and place it in the middle of a screaming, chaotic city street? The delicate acoustic waves are immediately battered by the roar of passing engines, the wailing of sirens, and the chaotic shouts of the crowd. The internal harmony of the music is not violently shattered by a single, magical event. It simply bleeds out into the overwhelming noise of the environment until it is completely lost and unrecoverable. This process is known as quantum decoherence, and it is perhaps the most devastating weapon in the arsenal of the skeptical physicist. Decoherence argues that we do not need a conscious mind to collapse the wave function, because the mindless environment is already doing it, relentlessly and automatically, every single fraction of a second. When an electron is fired through the double slits, it tries to maintain its fragile superposition, traveling as a wave of probability. If the laboratory vacuum were absolutely perfect, the wave would reach the screen and create an interference pattern. But if a single, stray photon of light, just one mindless, bouncing packet of electromagnetic energy, happens to ricochet off that electron while it is in transit, the environment has interacted with the quantum system. According to the unyielding rules of quantum mechanics, that stray photon becomes entangled with the electron, and then that photon bounces away and strikes a molecule of air, entangling the molecule. That molecule strikes the steel wall of the vacuum chamber, entangling the wall. In a matter of microseconds, the delicate, private quantum state of the single electron has leaked out into the massive, chaotic environment of the entire laboratory. Because the environment is so incredibly vast and full of random, thermal noise, the pristine phase relationships of the electron's wave function are hopelessly scrambled. The symphony is drowned out by the static. The quantum information is not destroyed, but it is dispersed so widely and so rapidly into the surrounding universe that it becomes completely impossible to retrieve. To our human eyes and to our recording instruments, the interference pattern simply washes away, and the particle appears to act exactly like a solid, classical object. Decoherence tells us that the universe is constantly, aggressively measuring itself. It does not require a biological eye, a firing synapse, or a divine intellect to force a collapse. A molecule of rock interacting with a photon of sunlight is a measurement. A grain of cosmic dust colliding with a stray hydrogen atom in the depths of space is a measurement. The crushing, blinding plasma of the early universe was the ultimate measuring device, a chaotic, boiling ocean where particles were colliding and entangling trillions of times a second. In this cold, sobering view, the 13.8 billion year paradox simply vanishes. The universe before anyone existed was never a ghostly, uncollapsed phantom hovering in the dark. It was a solid, definite, historical reality because the dense, chaotic environment of the early cosmos was relentlessly suffocating any quantum superpositions before they could ever scale up. The universe was baking itself into reality through the sheer, brute force of its own internal friction. The moon exists when you are not looking at it because the sun is looking at it, bombarding its surface with countless photons that continuously anchor it to the classical world. Reality is not a fragile illusion waiting for a conscious observer. Reality is the unavoidable consequence of a crowded, noisy universe. Yet, while decoherence provides a brilliant, mechanical explanation for how the delicate quantum wave breaks down and leaks into the environment, many physicists point out that it leaves a crucial piece of the puzzle unsolved. Decoherence explains how the menu of quantum possibilities is scrambled, but it does not fully explain why the universe selects one specific outcome from that menu. If a particle is in a superposition of spinning up and spinning down, decoherence explains why we only ever see one of those states, but it does not tell us what fundamental law chooses which state actually becomes real. It explains the fading of the ghost, but not the rolling of the dice. To banish the mystery entirely, to remove the observer and the need for a collapsing wave function once and for all, some of the most rigorous minds in theoretical physics have turned to interpretations of quantum mechanics that completely rewrite the underlying structure of reality itself. Perhaps the most famous, and certainly the most mind-bending of these objective theories is the many worlds interpretation. Proposed by Hugh Everett in the 1950s, this theory takes the equations of quantum mechanics entirely at face value and refuses to add any outside mechanisms, magic, or conscious observers. Everett noticed that the mathematics of the wave function never actually describe a collapse. The collapse was an idea added by physicists to explain why we only see one outcome. Everett simply asked, what if the wave function never collapses at all? In the many worlds framework, when a quantum particle is forced to make a decision, say, to pass through the left slit or the right slit, it does not randomly choose one and discard the other. It does exactly what the mathematics say it does. It takes both paths. But in doing so, the entire universe splits. Reality itself branches into two distinct, parallel, and mutually unobservable histories. In one branch of the universe, the particle goes left. In the other branch, the identically real universe, the particle goes right. When a human observer looks at the detector, their consciousness does not magically collapse the wave function. The observer simply becomes entangled with the system, and they too split. There is now a version of you who saw the particle go left, and an identically real version of you who saw the particle go right. Both versions feel completely unique, both feel completely conscious, and both believe they are living in the one true universe. The implications of this are staggering and deeply chilling. It suggests a multiverse of unimaginable, fractal proportions, branching infinitely trillions of times a millisecond with every quantum interaction across the entire cosmos. Every possible outcome permitted by the laws of physics is actualized in a sprawling, incomprehensible canopy of parallel realities. In this view, there is no need for a quantum god to hold reality in place, and there is no special role for human consciousness. We are merely riding one specific branch on an infinitely growing tree, entirely blind to the countless shadow versions of ourselves playing out every other possible destiny in the dark. It is a reality of sheer, terrifying abundance, completely devoid of unique purpose or centralized observation. If the sheer scale of the many worlds theory is too extravagant, there is another, entirely different objective interpretation that restores the comforting, mechanical clockwork of the classical universe. It is known as Bohmian mechanics, or the pilot wave theory. This interpretation suggests that the pioneers of quantum mechanics simply gave up on classical reality too early. In the pilot wave theory, particles are never ghostly waves of probability. They are never in a state of suspended animation, and they never exist in multiple places at once. An electron is always a solid, definite, tiny piece of matter, possessing an exact location and an exact momentum at all times, even when no one is looking. The weirdness of the quantum world does not come from the particle itself, but from a hidden, invisible wave that the particle rides upon. This guiding equation, the pilot wave, flows through space, rippling and interfering with itself much like a wave of water. The solid particle is simply swept along by the currents of this hidden wave. When we fire an electron at the double slits, the invisible pilot wave goes through both slits and creates an interference pattern on the other side. The solid electron, however, only goes through one slit, but its physical path is guided by the complex, interfering ripples of the wave. When it hits the screen, it lands exactly where the hidden currents pushed it. Bohmian mechanics is a completely deterministic theory. There is no rolling of the dice, no random chance, and absolutely no need for a conscious observer to collapse anything. If you knew the exact shape of the pilot wave and the exact starting position of the particle, you could perfectly predict where it would go, every single time. The universe, in this view, is a grand, flawless machine. The gears are just hidden beneath the surface of the vacuum, operating by rules we cannot directly see. The universe ticks on, silent, precise, and completely indifferent to whether humanity is holding a detector or looking at a screen. When we place decoherence, the many worlds interpretation, and the pilot wave theory side by side, a very different picture of the cosmos emerges. It is a picture entirely stripped of mysticism. It is a universe that does not need a cosmic witness, a participatory mind, or a divine architect to pull it out of the shadows. It is a universe that functions entirely on its own, driven by the cold, relentless logic of mathematics and the chaotic, blind interactions of physical matter. There is a stark, almost isolating beauty in this skeptical view. It demands that we let go of our deep-seated arrogance. It demands that we accept we are not the necessary linchpin of existence. The stars did not wait for us to open our eyes before they began to burn. The heavy elements were forged in the silent dark by mindless thermodynamic violence, entirely without our permission or our perception. The universe is a vast, unthinking engine, and we are nothing more than a brief, highly complex chemical reaction occurring on the damp surface of an ordinary planet orbiting an unremarkable star. We are not the architects of reality. We are merely its temporary inhabitants. And yet, there is a profound, grounding peace to be found in this demotion. If the universe does not require our observation to exist, then the sheer, physical reality of the cosmos is an absolute, objective truth. The ancient light falling on our telescopes is real. The ground beneath our feet is real. We do not have to carry the agonizing philosophical burden of bringing the universe into existence simply by looking at it. We are free to just be here, fragile and fleeting, bearing witness to a magnificent machine that was running long before we arrived and will continue to run long after we are gone. But science is not a monolith, and the debate over the quantum observer is far from settled. The skeptical interpretations, decoherence, many worlds, and hidden variables solve many of the mathematical headaches, but they all demand their own extreme philosophical sacrifices. They ask us to believe in infinite invisible universes or hidden deterministic waves that we can never measure. And for many of the greatest theoretical physicists working today, the core mystery stubbornly refuses to die. Because even if we can explain the mechanical process of measurement without invoking a human mind, and even if we can build a universe that functions purely on information and physical law, we are still left facing the most terrifying, foundational question of all. A question that sits at the very bottom of the rabbit hole, waiting patiently for any theory that claims to have solved the universe entirely on its own. Every grand theory of the universe, whether it is forged in the fires of mathematics, the quiet halls of philosophy, or the ancient traditions of theology, ultimately attempts to do one specific thing. It attempts to find the bedrock. When we peel back the layers of our everyday reality, moving past the solid illusions of classical physics and plunging down into the shimmering, uncertain mathematics of the quantum world. We are desperately looking for a flaw. We want to find the lowest possible level of existence, the absolute foundation that holds everything else in place. The measurement problem, born a century ago in the double-slit experiment, threatened to strip that foundation away entirely. It left us falling endlessly through a void of mere probability in a universe that stubbornly refuses to exist in a definite state until it is observed. To stop that agonizing fall, to find a flaw beneath the mathematical ghosts of quantum mechanics, many of the most profound thinkers of the 20th century arrived at the breathtaking threshold of the quantum God hypothesis. An ultimate observer, an infinite and omnipresent awareness, serves as the ultimate cosmic anchor. By constantly, flawlessly witnessing the entire cosmos simultaneously, this universal mind freezes the swirling waves of quantum potential into the hard, tactile reality we navigate every single day. It is an incredibly elegant, sweeping solution. It perfectly satisfies the strange demands of the quantum equations. It resolves the temporal paradox of how the early universe could exist long before biological eyes ever evolved to look at it. And it elegantly bridges the ancient, seemingly impassable gap between modern physical science and human spirituality. But human curiosity is a relentless, often unforgiving force. If you give a theoretical physicist an anchor, their first instinct is not to rest comfortably upon it, but to immediately dive into the dark to see exactly what that anchor is attached to. If we are to maintain our intellectual honesty, we must subject the ultimate observer to the exact same rigorous, uncompromising logic that we applied to the solitary electron in the laboratory. The fundamental premise that led us to this divine hypothesis is the realization that nothing in physical reality can become definite without an observer. A physical system remains in a blurry, undefined state of superposition until a conscious mind interacts with it, forcing it to commit. If we accept this as an absolute, unbreakable law of existence, we immediately stumble into the most terrifying, dizzying paradox in the entire landscape of human thought. If absolutely everything in reality requires an observer to become definite, and God is the ultimate observer holding reality in place, who observes God? How does the universal witness achieve its own definite state of existence? We are forced to ask if the ultimate observer is caught in a quantum superposition of its own. If the divine mind is a conscious entity interacting intimately with the physical universe to collapse its wave functions, the mathematics of quantum entanglement suggest that this mind should simply join the sprawling, universal web of probability. When John von Neumann brilliantly traced the chain of observation from the mechanical measuring device to the computer screen, to the human optic nerve, and finally to the biological brain, he assumed that the chain of entanglement naturally stopped at human consciousness. But if we scale that chain up to the level of the cosmos, to an infinite mind, the mathematics do not inherently provide a stopping point. The equations do not magically hit a wall just because the entity is divine. This realization opens the floor beneath us once again, dropping our minds into a philosophical nightmare known as the Infinite Regress. If the ultimate observer must also be observed in order to exist in a definite, concrete state, then cold logic dictates there must be a second, higher observer watching the first. We must imagine a meta-observer, sitting entirely outside the boundaries of our known reality, looking down at the quantum God to collapse its wave function. But the merciless rules of quantum mechanics must apply to this second observer as well. To avoid existing as a mere wave of probability, the second observer desperately requires a third observer to watch it, and the third requires a fourth. The fourth requires a fifth. Suddenly, the elegant solution of a single, unifying God shatters into a towering, endless hierarchy of cosmic witnesses. We are trapped in a dizzying chain of consciousness, stretching upward into an incomprehensible, never-ending infinity. It is a universe constructed of mirrors, reflecting mirrors, stretching out into the dark forever, with no original image ever to be found. An infinite regress is the ultimate failure of an explanatory theory. It means that the attempt to solve the deep mystery of existence has simply pushed the mystery one step further away, endlessly deferring the final answer. It is a road that leads nowhere. To escape this suffocating, infinite loop, theologians and some highly theoretical physicists argue that we must make a fundamental, structural exception to the rules. They propose that the ultimate observer is absolutely not subject to the laws of quantum mechanics because the ultimate observer exists entirely outside the physical architecture of the universe. In this view, God is not a physical system. The divine mind is uncreated, uncaused, and fundamentally different from the matter and energy it perceives. Because it is non-physical, it does not exist in a state of quantum superposition. It does not obey the Schrödinger equation, and therefore, it does not require a higher observer to collapse it into reality. It is the unobserved observer, the unmoved mover that ancient philosophers dreamed of centuries before the dawn of modern science. It is the one fixed point in a reality of fluctuating probabilities. But invoking this kind of structural exception makes the rigorously scientific mind deeply, profoundly uncomfortable. The scientific method is built on the premise that the laws of nature are universal. The moment you introduce an entity that is entirely exempt from the rules of physics, simply to save the rules of physics from breaking down, you have arguably stopped doing science. You have crossed the border into pure metaphysics. If we are allowed to simply invent an unobservable, rule-breaking force to cleanly tie up the loose ends of our quantum equations, a skeptic will rightly ask why we do not just invent a rule-breaking physical law and leave consciousness out of it entirely. This is the agonizing, beautiful tension at the very heart of the quantum mystery. After 100 years of relentless probing, every single attempt to solve the measurement problem requires us to accept something that feels fundamentally absurd to the human mind. If we embrace the skeptic's path of quantum decoherence and the many worlds interpretation, we are forced to accept a reality of sheer, terrifying excess. We must believe in an infinite number of invisible, parallel universes splitting and branching trillions of times a second, creating a sprawling multiverse where every possible version of history is playing out in total isolation. If we embrace John Wheeler's participatory universe, we must accept a reality where time itself is entirely fluid. We must believe that the fragile, biological minds of human beings existing today are actively reaching backward across billions of years of empty space to retroactively create the physical history of the Big Bang. And if we embrace the quantum God hypothesis, we must accept an infinite, unobservable mind that exists completely outside the boundaries of space and time, serving as a cosmic anchor in a sea of pure mathematics. None of these solutions are comforting. All of them shatter the classical illusion of the world we thought we knew. There is, however, one final, incredibly strange way to resolve the paradox of the observer without resorting to an infinite regress or supernatural exceptions. It requires us to abandon our biological obsession with linear cause and effect. It requires us to stop looking for a chain of observers stretching upward and instead embrace the geometry of a closed loop. What if the universe, the observer, and the act of observation are not separate, distinct things at all? What if they are perfectly identical? Imagine a cosmos that is entirely, beautifully self-referential. The physical universe, operating through the blind laws of chemistry and physics, generates the conscious mind. The conscious mind, possessing the unique ability to process information, observes the physical universe. That observation collapses the quantum wave function, giving solid, physical form to the very universe that generated the mind in the first place. In this breathtaking, circular reality, there is no need for an external observer looking in from the outside. There is no need for a hierarchy of gods. The universe observes itself. God, in this specific context, is not a separate, external being holding reality in place from above. God is the totality of the loop itself. The ultimate reality is an infinite, self-sustaining Ouroboros of information, matter, and awareness, endlessly creating itself in the dark. You are not a separate, isolated passenger moving through a dead, mechanical universe. You are an integral piece of the machinery. You are the universe's own mechanism for realizing its existence. When you look up at the stars, the universe is looking at itself. When you interrogate a subatomic particle in a laboratory, the universe is interrogating itself. Your act of looking is the fundamental process that weaves the tapestry of reality together. We have traveled to the absolute, bleeding limits of human comprehension. We have navigated a landscape where the hardest, most rigorous empirical science bleeds seamlessly into the deepest philosophical mysteries of existence. It is vital to state clearly what this journey has been and what it has not been. This exploration of the quantum realm is not a definitive proof that God exists. You cannot derive a divine creator from a mathematical equation, nor can you capture the infinite within the sterile confines of a vacuum chamber. Physics is not theology, and the equations of quantum mechanics will not hand you a religion. But simultaneously, this journey is absolutely not a debunking of faith. It does not validate the cold, bleak certainty of the strict materialist who insists, without evidence, that the universe is nothing more than a dead, meaningless machine operating in the dark. The quantum world has thoroughly destroyed the arrogance of classical materialism. The universe is undeniably far stranger, far more interactive, and far more deeply mysterious than the clockwork models of the 19th century ever allowed. What we have uncovered together is an honest, awe-inspiring look at the deepest, most unsettling question that the mathematics of humanity have ever blundered into. For exactly 100 years, our greatest minds have probed the absolute basement of reality. We fired electrons through slits. We split photons with crystals. We built massive colliders to smash the fundamental building blocks of the cosmos together at the speed of light. We went looking for the ultimate foundation of matter. But what we found at the bottom of the rabbit hole was not a solid floor. It was a mirror. The universe stubbornly, relentlessly refuses to let us remove ourselves from the equation. The physical world is intimately, inextricably bound to the presence of a knowing mind. The barrier between the objective world out there and the subjective experience in here has collapsed. Whether that collapsing mind is an infinite, divine witness holding the entire cosmos in a steady, eternal gaze, or whether it is the flickering, fragile consciousness of a human being looking through the lens of a telescope, the central, overarching truth remains entirely undeniable. Reality is not a passive, dead object waiting to be stumbled upon. Reality is a relationship. It is an event. It is a continuous, dynamic negotiation between the observer and the observed. As you go out into your life, as you touch the solid objects around you and feel the weight of gravity holding you to the earth, remember that the seemingly mundane physical world is built on a foundation of profound mystery. You are walking through an ocean of collapsed probabilities. Every physical interaction is a realization of potential. And as we look out into the vast, silent expanse of the night sky, staring across billions of light years of cosmic history, we are no longer looking at a cold, uncaring void. We are looking at a living question, hovering in a state of endless, majestic potential, waiting for us to answer it simply by opening our eyes and being here. We are the waking universe. Good night, and see you in the next video.